We're going to be finding the gradient of a curve. Now, the gradient of a straight line measures the rate of change of y, which is a dependent variable, with respect to the change of x, which is an independent variable. So we're changing x, and as we change x, y changes. That's what that means. Now, when the gradient of a straight line is positive, that means that the line is increasing. And when it's a negative gradient, that means the line's decreasing. And that's always the case. And as it is always the case, that means it's a constant rate. Here we have a graph, and it's a graph of a curve, and we're talking about a tangent in this situation. So a tangent is a straight line that touches a curve at one point. So here you can see it's this blue line here is touching the curve at this one point, just here. And as we get that tangent, you can see that for that particular point, that tangent has a positive gradient. Similarly, here we've got a tangent at this point, and when we have a point there, that means that we've got a negative gradient for that point when we have a tangent. And as you can see at the very bottom of this parabola here, we get a gradient of 0 because it has no slope. Now, as we're aware of this, we're not going to draw tangents all over this curve. We're actually going to do that later and see what the benefit of that is. But for the moment, once we've got that idea down, we can apply it to a situation like this. Here we've got an example. It says, write the sign of its gradient along the curve. So we've got this curve here, and depending on where the tangent would be, it would have a positive, negative, or possibly no gradient at all. So here we can see that if we had a tangent along this line, it would be positive. It would be going in the positive direction. So that means it's positive. And it's going to be that way all the way up this curve. It's just going to be a positive gradient up until the point here where it maxes out. So that's going to be 0. And then it changes, and then if we were to do tangent, it would be negative all the way down here. So that means that we're going to have positive up this way with no gradient here, and then negative down this way. Here's a slightly more curvier curve. We're going to do the same thing. So you can see here that as we move up this curve, it's got a straight line to the positive, and then it maxes out, goes to 0, and then it starts going in the negative direction. So we're going to have negatives there. And then it bottoms out here, so there's 0 again, and then it continues upwards, maxes out, and then it goes down again. Now we're going to see why that's useful probably in another video, but just make sure you understand where the gradient changes and how it works along a curve without necessarily drawing the tangents. Now, why this is useful, you'll see soon. We find the gradient of a curve by measuring the gradient of a tangent to the curve at different points around the curve. That's a bit confusing statement. You'll see how that works in a second. When we sketch the graph of these gradient values, y equals f dash x, and you'll see what that means soon as well, we get the derivative function or gradient function. So when we do this is shorthand for saying that we're doing the derivative function or the gradient function, which are the same thing. So we'll apply that to this example here. Given f of x equals x squared, okay, so remember that's kind of saying y equals x squared. So we're used to that. It's going to look like a parabola. It asks us to draw tangents to this curve at the points x equals -3, x equals -2, and so on. Then B asks to find the gradient of each tangent, and then finally draw the graph of y equals f dash x. So we're going to do that too. First of all, it asks to draw tangents to the curve at those points. And we know that this here is the x-axis, and at x equals -3, this is -3, we're going to have a tangent at this point, -2, tangent at this point, -1's a tangent at this point, 0 there, and so on. Once we've got that, I'm going to draw the tangents at each point. So we're going to have a straight line here. We're going to have a straight line here. Straight line here. At 0, this one's going to be hard to see. It's going to be parallel and overlapping with the x-axis. And then the same on the right hand side. Okay, so now we've drawn the tangents. At first that doesn't necessarily seem to make too much sense, but you'll see when we find the gradient of each tangent, it'll be a bit more helpful. Okay, so we know that f of x is x squared. That's quite important to know. And I'm just going to say, well, at x is equal to -3, we're going to have a gradient. And then same for x equals -2, we're going to have a gradient. And so on. And I'll just do x equals 3 over here. So when we're finding this gradient, we need to find, of course, the rise over run for each of these lines. We'll start off with the easy one. We've got this horizontal line at 0, so that means the gradient will be 0. But for the remaining tangents, when we're finding the gradient, we're going to have to use the y2 minus y1 over x2 minus x1. So I'm just going to fill in the rest, but if you need to, you can go back to the previous video to find how to find the gradient of a straight line. So for starting with x equals -3, we have -6. Remember, as these are all in this direction, they should all be negative, so we're going to have -6. M for x equals -2 is -4, -2 for -1. And then it's exactly the same values, just in the positive form, so we're going to have 2, 4, and 6. Now that we've found the gradient of each tangent, we need to go and actually just graph them on this graph. Now, here we had x and y. Now this time, it's actually going to be x, and y in this case is f dash x. Okay, and as we go through calculus, you'll see what this truly means. But at the moment, I'm just going to graph this. So now in this situation, instead of doing x and y values, I'm actually going to do x and the gradient, because the derivative function, as we said, is also the gradient function. So this is exactly what we need to be doing in order for this to work. So starting off with the origin, we have the point 0, 0, and then we'll go up, and then we'll go down. At point 1, 2, 2, 4, and 3 and 6. And then again, going down here, we've got -1, -2, -2, -4, -3, -6. And then when we connect these dots, we get our gradient function. Now, essentially what this is, it's a visual representation of the gradients of all the possible tangents on this curve. Okay, so as we're in this side, we'll have a positive gradient, just like we said in the previous example. Here we have a 0 gradient, and here we've got a negative gradient. So what ends up happening is, these in the positive, they're in the positive section here. These points in the negative, they're in the negative section down here. And then, of course, we've got 0 at the middle. Okay, and that's going to come in handy further down the line. But this is just a very important establishing point when we're talking about calculus. Okay, so here is how we can do exactly what we just did, but we're just going to bring everything together. Okay, so the first thing is we need to identify where the gradient is going to be 0. Because the question here, at the moment we're going to be sketching the gradient derivative functions just given the graph, no information aside from just the shape of the graph. From this, we're going to find a couple of things. There's going to be stationary points, minimum and maximum turning points. Okay, so our stationary points are when there's no gradient. So here we've got no gradient, here we have no gradient, and here as well. Okay, I'm going to call these some points. I'm going to call this x1. This one here is x2, and naturally that's x3. Okay, now that we have these ideas, I'm going to do exactly what we did in the first example. I'm going to fill in the positive and negative gradients of this curve. So here the gradients will be all negative up until that point there. Then here it's going to be positive. Then here negative again. And then positive. And what we're going to do with this graph is we're going to then sketch it back onto its axis, but as a gradient function of this curve, not the same thing as we're not just going to copy this down again. So here this is going to be x, and this is f of x, and then we're going to do here f dash of x. So when we're sketching the gradient function of the curve, I literally copy the exact same axis down. Makes it nice and easy to graph, because this idea it's a bit complicated, but with practice it becomes quite simple and it's quite methodical, which graphing sometimes isn't when you're talking about curves. Okay, so now I've copied that graph, I'm going to replicate all the x values that I established. So here we're going to have x1, that's going to be x2, and that's x3. So we got x1, x2, and x3, just to label them. Okay, now what we then do is, as these are stationary points, that means they have no gradient, they're going to be on the origin. Well, in this case, it's just the x-axis. Could be in the origin, depending on where it lies. So those dots are going to dictate how this curve looks. And essentially, wherever the line is negative, that means it's going to be below the x-axis. And wherever the line up here is positive, has a positive gradient, it's going to be above the x-axis. So essentially, we'll have a negative, so that's going to be below, down here. Then it's going to become positive, so it's going to be over the top of the x-axis. And then it goes negative again, so we go below. And then it goes positive again, so we're going to be above. So essentially that's how we draw this curve. Now this is going to be the derivative function, as we said, or the gradient function. Before we move on to the next thing, you'll notice I've written minimum and maximum turning points. Essentially a minimum turning point is where the graph bottoms out to a minimum point, and then a maximum is where it goes to the positive, it goes to the highest point. Now that doesn't have to be the highest point on the curve or the lowest point for the minimum. It just has to be where it peaks. So that's a maximum and their minimum, and they're all stationary points. Anywhere where the gradient 0 is a stationary point. Now that we've got that idea for this example, we'll do it again for this one. So first things first, we label where the gradient is 0, and then on the x-axis we label our x1 and x2, and we just keep them going if we need to. Next, I'm going to assign whether it's a positive or negative gradient along the curve. So here we've got a positive gradient, here's negative, and then here's positive. We'll copy the x and y axis again, using this graph as a basis. And anywhere where we labeled our x's, we'll do the same thing on our x-axis. So here we're going to have x1, and here is our x2. Now remember, we label those points. That's where the curve is going to go through the x-axis, and wherever it's positive here, it means it's going to be above, and anywhere where it's negative, it's going to be below. So you can see it's going to be above, below, and then above again. So essentially we're going to have a bit of a parabola going on. So it's above on this side, below here, and above here. Now because there's no numbers assigned, it's hard to tell how far we go down and all that. So just as long as you get the general shape, and you're showing that, well, it's a negative, so it's below, and it's positive, it's above, that demonstrates the idea well enough. that the marker or whoever's looking at what you're doing demonstrates that you know what you're doing.